Okay everyone, welcome back. In this video we are going to talk about wireless access points, or just APs for short. You can use the acronym APs for access points. Now I remember back in the day where wireless wasn't as predominant as it is today. In fact, a lot of organizations have moved away from providing physical cables. I remember back in the day when I first started out in the industry, we had to have cable guys come in and they would run a physical network cable to every single office. Well, in today's age, you don't really need to do that anymore, because a lot of times you're going to have desktops, laptops, tablets, phones. Everything has a wireless card that's built into it, and a lot of times it's a lot cheaper than running physical cables everywhere. It's not just cheaper from a cable management perspective, but it's also cheaper from a device management perspective. If you think about the amount of ports that you would need to physically plug in all of those desktops and laptops versus just hang 5 or 6 wireless access points, it's a lot different. You could have 100 people in your office or on your floor. You could have 200 people. Those are 200 individual cables that need to run back to a physical patch panel and connected back to a physical switch, versus maybe 10 access points that are still plugged into a switch. I'll draw that in a second. Still plugged into a switch, but 10 ports is going to be a lot cheaper than 200 ports. So what are these access points actually doing? How does this actually work in an environment? Now you think about today, where every store that you go into has wireless, right? Every Starbucks, every Target, every store grocery store you go into, and there's wireless, right? There's a way for you to connect to a wireless network. A lot of times it's a guest wireless network, so the SSID might be guest. The store, guest. You may have another SSID, and this may also be in your corporate environment where you have your corporate network. In fact, a lot of times in a corporate network, you're going to have a guest network for people to join that are coming in for meetings and things like that don't work for your organization. Other times you're going to have your corporate network that's going to be for your actual employees. A lot of times you also have a BYOD wireless network, meaning you have employees, but they're bringing their own cell phones in, they're bringing their own tablets in, and you want them not to be able to connect to your corporate network, and so you may give these guys 2 different passwords that you allow users to connect to. So how does this actually work? So I'm going to draw an access point here, and these access points, by the way, this is the symbol for wireless. So anytime you see the dot with the 3 kind of curved lines, that's going to be the symbol for wireless. So let's just draw that out here. So we have an access point. This access point is essentially emitting a wireless signal through the airwaves. I mean, really, that's all it is. If you go down and you take a specialization certification in wireless, you'll learn how all of those different radio waves and things like that work. But for your CCNA, you don't really need to go that deep. And so, we're going to have a tablet here, so we'll just put T. And this tablet is going to have its own wireless card that's built in, and it's going to also be emitting a signal. And these guys are essentially going to sync up. You're going to be able to detect this wireless network here that might be a guest network out in your grocery store, wherever you are. It could be, again, your corporate network. And that tablet's going to say, okay, what's the password? How do you want me to connect? And there's different kinds of passwords that you can use. You can use WEP, you can use WPA, and you can use WPA2. All of these offer a different type of a different level of security, a different level of encryption. You can also have you can also use AD. So you can use what we would consider 802.1x on your wireless, and you can say, okay, every time a user joins my wireless network, when they authenticate, they have to be an Active Directory user, and so we're going to essentially, that user is going to enter in their Active Directory username and password. The access point will essentially authenticate that user, and if they're on the corporate network, boom, they're good to go. Now that access point just isn't floating out there in space. It's just not there, allowing people to get on the internet. What it's doing is it's connected back to, and this is where all of these things come back together, it's connected back to a switch. Could be a layer 2 switch, could be a layer 3 switch. It really doesn't matter. What we need to be connected back to is a way for us to reach, typically in the Cisco world, our wireless LAN controller, or our WLC. Now these LAN controllers are going to typically be redundant, so you're going to have 2, 3, 4. You're going to have multiple LAN controllers throughout your environment. They do have wireless access points that are standalone, so in other words, they don't have a wireless controller. The individual endpoint, or the individual access point rather, is what's connecting to, directly out to the internet. The problem with that without a controller is that you don't typically have a unified network, so each access point would have to be manually configured on its own with its own SSID, with its own wireless, and then it's really, really hard to roam. Meaning, if you're in one part of that floor or that office or wherever you are, that one part of the building, and you're connected to access point 1, as you go across the floor and you connect to access point 2, it's really a completely different access point. It's considered a different network that you're connecting to because they're not joined. They're not a roaming system. And a wireless LAN controller allows you to have a roaming system where all the different access points that you have are going to be connected back to that switch, and they're all going to be communicating back to that wireless LAN controller and saying, hey, these are the amount of users that we're connecting, etc. So these access points are the endpoints that are, when I say endpoints, I don't mean an endpoint like your tablet or your desktop. That's what an endpoint is. These access points are at the end of your wireless network that are actually providing you with the wireless signal, allowing you to connect back into the network. Now, from that perspective, the access point is a very minimal job. Its job is to connect the devices, connect them as fast as possible, and it typically is going to have 2 different bands. And those 2 different bands that the access point is providing you have different qualities. So, for example, 2.4 is going to be a lower speed, so you're not going to get the amount of speed as 5G, for example, but you're also not going to be able to go as far. So, depending on the kind of wireless network that you're deploying, if you want to have 5G everywhere, you're going to have more access points because your users are not going to be able to go as far with 5G as they will with 2.4. But again, if you're looking for speed, you're probably going to want to go with 5G. Now, there's other things to consider as well. Remember that the access points are communicating over the airwaves, right? They're actually sending radio signals through the airwaves. I've worked in manufacturing places before where the machines out on the manufacturing floor, they emitted essentially sound waves that were disrupting the 2.4 gigahertz wireless. So anytime these machines were on, the wireless in that area of the building would actually go down and it would fail because the machines themselves were taking down the wireless network. And so in that area, we had to use 5G access points, and we had to use more of them because, again, even though things were faster, they didn't go as far, so we needed to use more access points. And we had to also have a transition point where, in other words, we had, let's say, 2.4, 2.4, and then we had a 2.4 and a 5 over here, 2.4 and a 5 over here, and then little by little we transitioned into just 5 gigahertz, and then we did the same as you left that area of the building where it would be 5, 5, 2.4, and 5, 2.4, and 5, and then ultimately just 2.4. So these are all the different things that you need to consider when deploying wireless. Now, the other thing to think about when deploying wireless are the channels. So wireless doesn't just operate on, channel 1. A wireless access point is going to have specific channels that it's going to want to communicate to your devices on. And typically this is something that's going to be automated by your wireless LAN controller. So you're not really going to have to pick your own channels, but again, it's just something to be aware of as you study and as you read through and as you get ready to take your exam, just something to keep in the back of your mind. Now, in the Cisco world, there's also something that you definitely want to play with and understand, and that is Meraki. I'm not 100% sure if they're going to ask any questions in your CCNA about Meraki. I know that Meraki has its own network associate certification, which I've taken and have, but just in case it ever comes up, again, I also want to teach you real world stuff. Meraki still does have the concept of a wireless LAN controller. It just does it from a cloud-based model. So what I mean by that is you're going to have multiple access points that are connected, and they're still going to have to go back to a physical switch because they need internet access. But from that point, those access points are going to communicate directly back out to the cloud in order to connect to your Meraki portal, where you'll go and you'll configure however many corporate networks you want, SSIDs that you want. You'll be able to configure the passwords and the things like that. And so this is where this is essentially what access points are doing. Their job, again, is just to connect as many endpoints as possible. By the way, you also have to think about the limit and scalability of the access point. In your CCNA, you're probably not going to get too deep into this, but again, real world knowledge, if you're really a network admin out there, you're not just going to put one access point for 50 different, endpoints that are connecting on that floor. You're going to want to understand the scale limitations of the access points that you're purchasing. You're going to want to understand how many endpoints can connect to it and still get a certain amount of speed. And that, again, is going to dictate how many access points you need to put in that area and where you need to cable them back to. And that's also going to dictate the channels that those different access points are going to be able to use within that spectrum. So hope you enjoyed this video. I'll see you guys in the next one.